Hello. In this video, I want to show you how you can use the data loader with Spring for GraphQL to avoid 1+n problems when processing your GraphQL requests. To give you a short example, I'm using the Spring Pet Clinic example with the GraphQL API. And the first thing I want to do is I want to run this query that asks for visits from our backend, the visits for the pet with the ID 7. And from each visit that is returned, I want to know the ID of the treating veterinarian that has done this visit. We also enable some trace information so that we can see what the server actually is doing. So let's execute this query. And you see the data is returned here. We got two visits, visit number 1, visit number 2, with two different veterinarians, ID 4 and ID 3. In our extensions field, we have the tracing informations, and inside the tracing information, we have this execution field, and in the execution field, we have a list of our own data fetchers. This list of data fetchers does not contain the trivial data fetchers that are the built-in data fetchers that work, for example, with reflections. This list only contains our own data fetchers that we have implemented our own. And you will see in this list, we first have a data fetcher that returns the value for the field visits. That is the list of visits, obviously. And this data fetcher loaded two visits from the database. And for each of these visits, another data fetcher for the visits treating vet field is invoked. And each of these additional data fetchers is calling a REST endpoint, a REST microservice, to get the information of the requested veterinarian. And both of these REST calls are done one after the other. So we have one database call and two REST calls, and this is a 1+n problem. One database call, n other calls, in this case to REST endpoint. The first thing that we could do to improve our situation, you can see we have a rather large overall execution time here with about 580 milliseconds. The first thing to make this situation better is that we can implement this data fetcher that are making the REST calls reactive so that they can run in parallel. Let's do that. Going to the IDE, and here we have our schema mapping function that is responsible for loading the veterinarian from our microservice. The visit has an ID, has a vet ID, and if it has a vet ID, then the microservice is queried to get the information about the veterinarian. And we simply can change this function here from a synchronous function to a reactive function by changing its return value to a mono, to a reactor mono object. Of course, we then have to adjust this call also. I've already prepared a function that returns a mono object here, so we can just change this. This vet by ID method uses the Spring Web Client to make a reactive call to our microservice. So now we have a reactive handler function here, and that means that more than one of these handler functions can run in parallel. Let's try that out. And we run our query again. And you see now the overall query execution time is slightly faster, down from 580 milliseconds down to 324. And you can also see that both data fetchers for the treating vet are run on two different threads, Reactor HTTP NIO2 and NIO3, and they also are started more or less at the same time. So they run in parallel, and the overall execution time is now faster. But we still have the 1+n problem because we still have one call to the database and two calls to our REST services. And we have also another problem. Let's query the pets for let's query the visits for the pet with the ID 8. I run the query, and you see we have here 4 visits, and among these 4 visits we have 2 visits that have the same veterinarian with the ID 4. Now when we look in our list of data fetchers, of course, it starts again with the visits data fetcher that now loads 4 visits from the database. And we have 4 REST calls to our REST service. And the problem here is that we have 2 REST calls with the same ID, 4 in this case. So this REST call might be required, the second might be required, and also the third may be required. But to load the same data 2 times in one query for the same data for the same resource is obviously not a good idea. So it would be better to batch these calls together. And that is a situation where a data loader can help us. So let's implement a data loader. A data loader allows us to defer the actual loading of data to a later point in time in the query processing. For that, we need a data loader in our query handler. And in this case, we need a data loader that takes IDs or keys of type integer, because that is the type of our primary keys in this application. And the data loader should load for this integer IDs that resource objects. That are the resource objects that are coming from our REST endpoint. Now, instead of making the actual REST call in our schema mapping function, we delegate the call to the data loader. We will implement that in a minute, but for now we just delegate it to this data loader. And we're doing this by invoking DataLoader.load, and then we pass the ID that we want to load. Visit get vet ID. We return this, return. Then we have to change the return value here. This is a completable future now. And we can leave this out. So now our schema mapping function is called for each visit, still for each visit. So if we have 4 visits, the function will still be called 4 times, but it doesn't make 4 REST calls. It just invokes our data loader 4 times and stores 4 vet IDs in our data loader. Now, of course, we have to implement the data loader that is injected here. And for that, I'm going to the constructor of our controller class here. And we can receive an instance of a batch loader registry. Don't be confused that there's an error here. That is some bug in IntelliJ or in my setup. I don't know. It's completely possible to get an instance of batch loader registry with Spring Boot. Now we can use the batch loader registry to register a batch loader or a data loader for the type pair integer class, that is our ID, and the class of our object that we want to load, which in this case is a vet resource. And for this type pair, we want to register a batch loader. And a batch loader is a callback function that takes 2 parameters, the list of the keys or IDs that we added here with the load function. This is the first parameter. The second parameter is a batch loader environment that we don't need for this example, but anyway. The responsibility for this batch loader function that we've written here is now to load the actual objects for these keys. Inside our schema mapping function, we add more and more keys to the data loader, and some point in time, the GraphQL execution infrastructure invokes our function with all collected keys, and we can now load the data for the keys. And in this case, I will add some logging information so that we can see what's happening here. Loading vets with keys. And then we use the vet service client, and there's a function called find vets with IDs. We can pass the keys, and returned is a flux object that emits vet resource objects. And the contract of this batch loader functions is that it has to return a flux object emitting the objects you want to return. So we can just return this object. And in this case, this function is doing exactly one call to our microservice, giving all keys, giving all vet IDs to this microservice. The microservice can then return a list of the requested veterinarians. Let's see if that works. I rebuild the application and we're going back to GraphqL and rerun our query here. So now we see we have again 4 visits here. 4 visits are loaded from the database, but now you see the actual invocations of the data loaders are very, very fast, 10 milliseconds, 11 milliseconds, because they don't do anything anymore. They just delegate to the data loader. So now we see we have again 1 query to the database. We have 4 times our schema mapping function called, also with this duplicate ID 4. But then in our data loader, this is the logging from our data loading, we receive an array with only 3 entries, 1, 4, and 2, and the duplicate 4 is removed. So your data loader only receives each key 1 time. And then we are doing 1 HTTP request and load 1, 4, and 2. And then we have 1 database request and 1 REST request. I think this is the best situation you can have, that you have an endpoint, an API, a database call, whatever, where you can put in or pass in multiple keys, multiple IDs, and then load very efficiently many objects in one request, be it a database request or be it a REST request or whatever for a request. Now, unfortunately, that is not always possible. So I have another method here, and that is not called find vets with ID. It's called a little bit different. It's vets with ID. And this function, again, is doing multiple requests for each key, 1 request. So it's somehow back to where we started. But this is, again, reactive. And also, we don't have 4 requests. We have only 3 requests compared to the reactive schema mapping function. I clear the logging and we re-execute. And now we see loading vets with 3 keys, 1, 4, 2. And now the thing is that we start 3 HTTP requests more or less in parallel. This 3 HTTP requests took a different time. And you see that the request with the ID 1 come back first. Then the second request was for the ID 4, but this come back as the last request here, as the third request. And the request for the ID 2 comes back in second place here. So the order that we started our requests and the order in this array 1, 4, 2 is not the same as the result here. And now we have a problem because the assignment key to vet object is wrong. Let's see how this looks in GraphqL. I slightly modify the query, and I can not only ask for the treating veterinarian itself, but I can also query its ID here directly on a visit object, treating vet ID. And if we run this now, you will see we have treating vet ID 1 and also the first treating veterinarian, which is fine. But here in the second visit, we have asked for the treating veterinarian with the ID 4, but received 2. Here we have asked for the ID 2 and received 4. So there's a mismatch. And the thing with this data loader is that you have to make sure that the list of objects you return matches the order of your keys. This must be the same. If you have key A, B, C, then you need to return the objects in order A, B, C. And that is what's not happening here, because this returns the object in any order. We have no guarantee that we get back the objects in the order we asked for. If you have this problem, that you have to make multiple calls and you cannot guarantee the order in that the calls are coming back, then you can implement another batch loader, and this is a so-called mapped batch loader. Let's implement that. You can also register this on the batch loader registry with the 4 type pair, but now we register a mapped batch loader. And the signature of the map batch loader function is slightly different from the normal batch loader. We receive a set of keys. Then we have our batch loader environment that is the same, and we still don't need it for this example. And now the return type of this matched batch loader is not a flux object, but it's a mono object of a map of keys to object vet resource. So this is the return type of this concrete matched batch loader. For each key, we add an entry to this map, and the map must then be returned as a mono. So again, let's add some logging to see what happens. And then we use this function again to load our objects. And in this case, we have to map our result into a map, into a mono of a map. And we can do this in this case like that map.entry.id.v. This is creates an entry for each returned vet resource. We create an entry object, and then we collect this with a collectors.toMap function. And here we use map entry get key and map.entry get value. This one. And then we return this, of course. So this function still returns a flux object that emits unordered vet resources, and we put that into a map and return this from our mapped batch loader. The batch loader not only batches multiple calls together, but it only works as a query cache, or a cache for the data that is loaded inside one query. And I can show you an example for that. We slightly enhance our query. We not only query for the visits, but we also query for an owner, its pets, and the visits of the pets, and the treating veterinarians of the visits of the pets of this owner. Let's execute this. Of course, as before, we receive our 4 visits from this first part here. And then we receive one owner and its pets. And the visits of these pets also are done by our known treating veterinarian with ID 1, 4, and 2. So we have the same veterinarians here below in the second part as in the first part. But in the second part, we also have a veterinarian with the ID 3 that we don't have in this first part here. So let's see how this more complex query is handled in the backend. Of course, it first starts with loading the visits from a database, then loading the vets for the visits that we have already seen before. In the meantime, it also loads the owner 6 from the database. The order here in general is more or less random because there's so much async code involved, so that the order might change slightly between different executions of the query. But then the map batch loader for the first part of our query is invoked and loads the vets with keys 1, 4, and 2. You see the requests are starting and the requests are running in the background. In the meantime, the GraphQL execution engine starts to process the second part of our query, the owner query, and invokes the schema mapping functions again for the vet. And we are loading vet 1, 4, 2, and so on from our REST endpoint. But now in the second part of our query, in the map batch loader, only the vet with ID 3 is requested, because the vet with ID 1, 4, or 2 are already loaded in the first time here. So then there's also the HTTP request started for the vet with ID 3, and then all these HTTP requests are returned. And that these HTTP requests are returned here at the end of the processing is also more or less random. That depends, of course, how fast or how slow this responses are. So it might be possible that in real life, for example, the first request might be finished somewhere here. But the important thing is that we have already loaded some of our object that we needed, and these objects are cached. And when they are again needed somewhere later in the query, they don't have to be loaded again. So a data loader acts as a cache for objects inside or for one query. It's not a cache among multiple queries. If I would run the query again, then the same REST calls would be made, but inside our query, it acts as a cache. So we have seen data loaders, batch loaders, mapped loaders, and also completable futures as return types of schema mapping functions. All these are things that you can use to improve the performance of your GraphQL query. So I hope you like this video and you get an understanding what data loaders are and how you can implement them and use them. Enjoy building applications. See you next time. Take care.